Binary operation. A binary operation of a set A is a function from the subset of A times A into a set B. It is a kind of mapping or function where two elements A times B all being combined by means of the given operation with result in a single element B. We call A times A as a domain and the element of B as a range. Under the indicate binary operation, D is closer under. But notice that under the set of positive integers, Z positive is that close under. Since based on the computation above, 2 times 5 equals negative 3 is not element of 3. We have the properties of binary operations. First, commutative law for this symbol. Note that we always point out the operation or division is not commutative under the set of numbers. For example, 3 divided by 5 is not equal 5 divided by 3. Second one is associative law or for the symbol. It we use the define about as A times B is equal to A plus B minus AB. Then to verify the associative, we have left side and right side. And the last one is distributive law for over degree. Notice that there are two binary operations involved in this property. For example, in algebra, A B plus C is equal to AB plus AC, where we say that multiplication is distributive under addition. There are two kinds of distributive law, and these are as follow.
So what is zero divisor? So let's formally define this element. We say a non-zero element A and the integers modulo and Z is a zero divisor if the equation AX equals 0 has a non-zero solution. So basically, this means that you have the product of two non-zero numbers equally. So let's look at an example. We want to find all the zero divisors in sigma 8C. So the simplest way to illustrate is to set up the table given the example. The first row are all going to be 0 since this is multiplication. And similarly, the second row in the second column, you're multiplying by 1 and so you're just getting elements of 3 modulo of 8C. So let's look at the third row that it had need to be filled in, so we started with 2 times 0 with 0, 2 times 1 was 2. And then the next thing we do is 2 times 2 that equals to 4. 2 times 3 is equal to 6 and 2 times 4 is equals to 8. But 8 is equal to 0, so it is modulo 8. If we keep going, we get that 2 times 5 is 10, which is congruent to 2 modulo of 8. 2 times 6 is equals to 12, which is congruent to 4 modulo 8. And 2 times 7 is equal to 14, which is congruent to 6 modulo of 8. Now let's jump down to 5th row. We have 4 times 0 is equals to 0, 4 times 1 is equals to 4, 4 times 2 is equals to 8, which is equivalent to 0 modulo 8. 4 times 3 is equals to 12. 4 times 4 is equals to 16, that is congruent to 0. Now we have 4 times 5 is equals to 20. So 4 times 6 is equals to 24, another 0. Finally, we have 4 times 7 is equals to 28, that is congruent to 4. We filled our table. We have 5 areas. where we get the product of two non-zero numbers equally 0. Then 2, 4, 6, 8, and 0 are the zero divisors and z modulo 8z.
Performing binary operation using table. This section aims to: first is to distinguish the binary operation from the ordinary basic operations of arithmetic, and second is to perform binary operations based on tables. We continue performing binary operation using values from table. Example: using the table, test the properties of binary operation such as A. Commutative, B. Associative under the set S. Solution: first, commutative. Based on the table, the elements are symmetric with respect to the main diagonal. This indicates that star is commutative under S. B. Associative. We test the property applying a few cases as follows. The quantity B star C star D is equal to B star the quantity of C star D. D star D is equal to B star A. B is equal to B. The quantity of D star B star C is equal to D star the quantity of B star C. C star C is equal to D star D. So B is equal to B. This kind of computation will hold for all cases of the element in S. Thus, star is associative in S. Example: let me give you a set, therefore, element 5, 6, 7, and 8. Let me now give you a binary operation star. On this set, that is defined by this operation table, in the operation table, we have denoted A star B as the entry in the column headed by A and the row headed by B. Now, what we need to find out is whether the binary operation star is commutative or not. A binary operation star on an A set A is called commutative. If A star B equals B star A for every A and B that belong to the set A, so let's take the commutativity of star, and you see that 5 star 6, that is the entry in the column headed by 5 and the row headed by 6. Yes, we are talking about this element, so 5 star 6 equals 7. And what about 6 star 5? Look at the table, 6 here, 5 here, this element, so we see that 6, 4, 5 is also 7. And this tells us that 5 star 6 equals to 6 star 5. In fact, if you go on checking, you will find that this argument is true for all the elements of the set with us. What this means is x star y equals y star x. For all x and y that belong, put this set. So now, we know that time of variation star is commutative. Alright? Let me now ask you another question. Does there exist any identity element for the operation star? So, let's find out the answer to this question. Now, we know that for a binary operation star that is defined from A times A to A, an element A that belongs to set A, if it is exists, that is called its identity element if A star E equals A equals E star A for all A that belongs to set A. Now, look at the binary operation table. So let me write down a few expressions. 5 star 8 that equals 5, that in turn is equal to 8 star 5, 6 star 8 that equals 6, that in turn is equal to 8 star 6. Similarly, I have written two other expressions. So, what can you say now? Is there any identity element? Of course, yes. What is for the binary operation star now that we have found out that identity element? Let us also see whether the inverses of all elements of this set exist or not. Now, for a binary operation star that is defined from A times A to A with the identity element E, an element either belongs to set A, said to be invertible if there exists B that belongs to set A, such that A star B equals E equals B star A. So, what are the elements of the set here? 5, 6, 7, and 8.